Hi class, this is number 8 on 12.3. I need to open these rooms really fast. That is not, I'm getting there. Okay, here we go. The table shows the mileage driven by the UPS driver. The distance is the total number of miles he has driven. Okay, the table shows the miles driven by the distance is the total number of miles he has driven. So I guess, okay, so like he is given the number of hours. If he drove for 0 hours, then he drove a distance of 0. If he drove for 1 hour, that means he drove 43 miles, 2 hours and 87, 3 hours, 110, and 4 hours, 120. And they ask us to determine a linear regression equation for the data, and then round the slope and y-intercept to the nearest whole number. Okay, so all we have to do is input all this data. You're going to put it in, you're going to go test it, stats, edit. In L1, you'll put the time. In L2, in your second list, you'll put the distance. And then you'll go in and you'll do, I think it's like stats, calculate, and regression line, a reg line. And you'll put in your, where you put your data, L1 and L2, and then it'll calculate this line for you. I'm going to do it in class calc. With class calc, I just Googled, I just used this website right here, just class calc, and then I just press Google, and then like I found it just takes you to the graphing calculator. Okay, and I go to stats, and then I go to advanced, and then I go to LIN/reg, so that's linear regression. And don't confuse that with, there's another one that says like LG regression, and other ones are kind of similar, but don't mix them up because it's not going to get you the right answer. Okay, so I just press linear regression, and then all the numbers in that first list, I'm going to enter. So the 0, 1, 2, 3, 4, 5, 6, 7. So that's not going to be hard. Let's see. Let's just put that in for my first list. 0, 1, 2, 3, 4, 5, 6, 7. Okay, and then I put commas in between them. The next one, 0, 43, 87. It's going to be a little bit more time consuming. 0, 43, 87. 0, 43, 87. And then it's going to take me a bit to put all this in. 110, 120, 150. 110, 120, 150. And 203 and 216. 203 and 216. Okay, I think I got them all. I think I did them all. Yeah. Okay, 216, 203, and 216. Yep. Okay. And then you just double check your numbers. Just to 0, 43, 87, 110, 120, 150. Okay, that looks good. 203 and 216. Okay. All right. And then automatically, I didn't even have to press enter or anything. As soon as I put my list in, it gave me the equation. And it also gave me the R, the coefficient of correlation coefficient, and then like the coefficient of determination. So it gave me everything. And they said just what they wanted was they wanted us to round both these numbers, this 29.89. They wanted me to round that to the whole number. So of course I'm going to say 30, and they wanted me to round this to a whole number. So I'm going to say 12. So we're going to say 30x plus 12. I just took all the decimal numbers and rounded them to whole numbers and write everything in there. So let me input this. So I'm going to say y equals 30x plus 12. And there we go. All right, and let's just double check that that's exactly the answer that they got. So that looks good. Okay. Then they said interpret the equation in terms of the problem situation. the slope means. So the slope given, it is the amount of movement, I believe, in the it's the rise over the run. So amount of movement in the y coordinate, or the dependent variable based on one movement of the independent variable. So over 1 hour, because it's the change in y over the change in x. So it's the change in distance over the change in just 1 hour of time. So it means that in about 1 hour of time, they go 30 miles. So let's see which one best says that. The predicted increase per hour is 30 miles. Yeah, that's exactly what I would describe it as. Yep. Okay, and then the y-intercept means, so the y-intercept means if I have driven, if I have gone no miles at all, right? Or if I've spent no time driving, because the x value is our time. If I spent no time driving, if I plug in 0 for x, then that would mean that would give us the y-intercept. So if I spent no time driving at all, then I began 12 miles away from, I guess, I already was at a miles of 12 miles away. So maybe he actually lives closer to his location that he wants. So when he left his house, he was already 12 miles from maybe the warehouse or whatever, and 12 miles on toward his destination that he wanted to be. So I would say, yeah, at the beginning, before he even started driving, he was at mile marker 12. So the y-intercept, let's see, it definitely has something to do with 12. So I would say it's not any of these that say 30. I wouldn't say they're not it. But the predicted increase in miles driven per hour, no, that's like slope, like something miles per hour or whatever, that's slope, because that's this over that, no. The predicted number of miles driven at the beginning is 0, no. The predicted number of miles driven at the beginning is 12. Yes, that's the one we want. Which is kind of ridiculous. Like, you haven't been driving at all, but maybe, who knows? Maybe that we have a situation where he would do, like I said, they live closer. Okay, find the correlation coefficient, R value, and they already spit that out for us. The calculator just does that for us, right? So that is this 0.9885. Or I would say to 6, okay, 0.9886 to 4 decimal places. So we would just put that in. Yeah, 0.9886, and that's exactly what they get. And then they say, what does the correlation coefficient tell us about the regression line? So the closer it is to 1, the more linear that relationship is. If it's 1 or -1, all the points perfectly line up on a line together. So, and it's positive. You can also look at the fact that this is a positive R, so it's really close to +1. So I would say the line is, I would say the line is a good fit because it's close to +1. The line is a good fit because R is close to +1. So that's the one we want. Yep. The line is a good fit because we're close. Okay. And so basically always the closer it is to 1, the closer it lines, all the points are lining up on exactly on a line. And if it's kind of close, I don't know, if it's above like 0.6, or 0.7, I don't know, I would start to say it's a strong relationship. And then like above 0.7, below 0.7, like between like 0.4 and 0.7, I would say moderate, I guess. And then like if it's below 0.4, I would say like there's almost no relationship at all. But okay, predict the distance the driver would have traveled over after 11 hours. So this is the big one that here they want us to use this equation up here, because this equation, it's perfectly set up for, if you give me an x value, then we can multiply by 30 and then add 12 and then find the given corresponding y value. That's what this equation does. So to find this line, that's what you usually want a formula for, is to predict some kind of thing in the near future, or use data from previous data to predict what might happen in the future. That's our main thing we like to do for this. And we just have to plug in the value. It says predict the distance the driver would be traveled after 11 hours. So do we plug, is the 11 hours the X or is it the Y? Well, if you put your L1 in first and your L2, if you put this as your L1, and this is like your first list and not your second list, and then most likely you set it up so that your X is going to be the time and the distance is going to be the Y. However, you can kind of double check to make sure that is the case, because when I plug in 0, I should get something kind of close to 12, or, you know, kind of close to whatever the predicted values. These should kind of match, you know? So, I mean, if I plug in 2 for here, I should get a number kind of close to 87. You know, and if that's, this X is representing these times, then when I plug in this 2, I should get 87 back for the Y, and then, or something close to it. But here the X is the time and the Y is the distance. So I plug in the 11 where the X is. That's what it really helps. You're like, where do I plug in what, where? Well, pay attention to the units of each variable. The units on this X are time, it's hours. And the units on the Y are the miles. So I plug in the 11 hours. Because it was an hour, I know I need to plug in all my hours for the X. I have to, when I plug things in, it's good to put them in parentheses. And hopefully you guys know that when you have a number and a variable placed right next to each other like that, there was a multiplication going on between a 30 and the X that was being multiplied. So we have to still multiply it. And if we have a number in parentheses next to another number that is also indicating multiplication, right? That's the correct thing to do. So do we use addition and multiplication, but we always do the multiplication first, and then we do the division. I'm sorry, then we do the addition here. So then we just take our calculator. Back to our class calc. This fast calculation here. So 30 times 11. Okay, that gives us an answer. And then I'm 330, and then I'm just going to do 330 plus the 12. And there we go, 342. And that is using the line that we came up with. We were able to predict that it's 300, that if they did drive for 11 hours, they should drive about, that it would take 342 miles. All right. Now do watch, because for this part D, it is very common that they may also, I mean, this one, they give you miles, they ask for, you know, I'm sorry, they give you hours, they ask for miles, right? But this equation could go the opposite way as well. Like they could give you miles and ask for the hours. And in that situation, we would have plugged in Who did plugged in for y? So if they gave us a problem where they give you the miles, say they gave you 40 miles or whatever, then you'd plug in the miles for the y, and then you'd say 40 is equal to 30. And if they're asking for the number of hours, then you could solve algebraically by isolating the x by itself and finding out what, is that 28? Yeah, okay, 3, 8, okay. And finding out how many hours that would be. Okay, oh wait, could divide by 30 on both sides. Hello, I need to focus here. And then get 28 parts of 30. Okay, so so that could be going both ways. When you have an equation and you have two unknowns, if you're given one unknown, one of the two unknowns, then you could always find the other unknown. So you could either be given the x and asked to find y, that is given in hours and asked to find miles, or you could be given the miles and asked to find the hours. Now, what changes is that they're very similar. It's a very similar problem. What changes is where you plug the variable in, whether it's the y or the x, and which variable you're solving for, the x or the y. And notice this equation is it's built so that you can easily plug in the hours and you easily get the miles. However, we could algebraically write that same equation in a different way where it's easy for me to plug in miles and get back hours. So it takes a little bit, so that if you're given miles and you're asked for hours, there's more work. You have to solve algebraically for the problem. So that's a more involved problem. But most of the time they give you the independent variable. And so usually it's you just plug it in, you follow order of operations and you get your answer. All right, let me know if you guys have any questions. Bye.